Secondary constraints or secondary resources provides Opcenter APS great flexibility to configure real-life shop floor capacity limiting features. It's often used to module headcount, so people, skilled people, groups of people, tooling, material. There are ways to configure secondary constraints so material availability can be module using secondary resources. Also tanks and the ability to provide liquids and materials to an operation before the operation completes, for example. But the bottom line is you're going to need to understand how in reality your shop floor is behaving, and translating that into Opcenter APS requires high knowledge of how the system behaves and what features the system provides. So it's highly advised to work with an integrator in order to properly create and configure those secondary constraints. Okay. In this video, we're going to cover the basics of secondary constraints. And in order to do so, I added here in the overview window the plot, and I created this constraint A, and I decided to not give you it a proper name, just for you to understand that it can be anything. So double click in the operation here in the resource button, we have secondary constraints. Right now I have none. You see that I have all of those available, but I have none activated for this operation. What I'm gonna do, another point is that what I'm gonna do here manually, often it's done automatically by an integration process, okay? So keep that in mind as well. When I add constraint A, if I double click it, I have two fields here, constraint usage and constraint quantity. Constraint usage is the behavior, how the constraint will be consumed or applied to the operation. And constraint quantity is the quantity itself. It can be a fixed quantity, so for example, 1 here. So for example, this right here is telling that to run this operation 10 profiling during the process time, during the entire job from the beginning of the setup time to the end of the process time, I'm gonna have one, I'm gonna consume one of this constraint, okay? So let's hit OK here and see the chart. You see that now, after this manual change, the utilization plot goes up to 1 and goes down to 0 for the whole duration of the operation, from the beginning of the setup time, from the setup start to the end time of the operation. Take a look here at the bottom of the chart. We have the name of the constraint and the default minimal and maximum value, right? So I have a maximum value of 700. That means that I am okay, right? So if I have a maximum of 700 and I only consuming one, that means that I have plenty available to run this operation at this time. Let's take a look here at other quantity options. If you click here, you have remote fields that you can select. You can either type a value, again, 5 for example, or you can select quantity, which is exactly the order quantity here, the operation quantity. Or you have numerical attributes that can also be utilized. Of course, this list can be increased. This is what comes by default with the system. And you can also rename those fields. Numerical attribute one can just be renamed by what this number actually is. So selecting the quantity here, take a look that I have a 400 quantity operation. So now my expectation is that this chart needs to go up to 400. And that's exactly what happens here, okay? So coming to attributes, you see that numeric attributes 1, 2, 3, 4, and 4 have value associated to them. So if I select those in the secondary constraint here, let's say numeric attribute 1, then the value of that chart also changes. You can check what is the actual value running here by drag and drop in the chart, you see on the bottom, at this region here, at the bottom right, you see what is the date and time, the current minimal, the current maximum value, and the current utilization value, so 79.71, which is the numerical attribute 1 value for this field over here, for this operation here. Okay, so this is about the quantity, and very often you want to use the quantity, operation quantity in the secondary constraint field. For example, if you want to control your warehouse maximum size, right? So you can set up a constraint that says this warehouse has a maximum, can store a certain quantity of this type of product. And then as your operations will be controlled by that, okay? Coming back here, looking at the constraint usage, you see that they have pairs. So they have increment from start, decrement from start, increment for end, decrement for end, increment for process time only, decrement for process time only, and so on and so forth. So here, increment for entire job, decrement for entire job. The only exception to this rule is the no change. So the no change is basically doesn't do anything. It's used if you want to include a secondary constraint to an operation, but you do not want to constrain it by any means, or you don't want to even take a look at the plot chart for it, right? So it basically has absolutely no capacity constraint impact, okay? So because we have pairs, increment and decrement, I'm going to first only talk about the increment, okay? And then I'm going to talk about the decrement. So let's start from the top. So increment from start, when you select this option, you see that my constraint goes up to the quantity here. So let me change the quantity to just to be the order quantity, because I believe this is easier to understand. Okay, so increment from start, at the start of the operation, so at this moment here, my constraint is goes up to its maximum value, to its quantity value, which is 400 in this case, and it goes up. It keeps the utilization remains the same until the end of Opcenter APS future planning horizon. So it goes to infinite, let's say. This here, it's very often used to control, again, material allocation, warehouse limits, or any other type of constraint that can take advantage of this type of utilization. So coming back here to resources secondary constraints, the next one is called increment for process time only. This is the default one that whenever you add a new secondary constraint, this is going to be the one selected by default. So essentially, this is following the process time of the operation. So you see that drag and drop here, you have the constraint following up this, and it goes up to its maximum, stay using the maximum until the end time of the operation. This can be useful, for example, for headcount, tooling utilization, and any other type of resources that you use while the operation is running. So looking at here, just to explain what you're seeing, remember that those are off-shift periods, so zero efficiency. So even though the operation looks like it's running, actually the operation is split into two different periods here. One before the off-shift, then after the off-shift. So during this period here, there is absolutely no process time. In consequence, there is no utilization of the secondary constraint. You can change this behavior, but I'm going to show that later on. Okay. So coming back here to secondary constraints, after that we have the increment to end. So let's take a look at this. This here is very useful whenever you are modeling material allocation using secondary constraint or tank or process operations such as the tanks and liquid operation as well. So imagine that you constantly add liquid to a tank, and when this tank reaches a certain quantity, then you can start further operations, right? So that's exactly what's happening here. So by default, the operation is split into 100 equal steps, right? But you could also change this to be less or more steps. So you can see that it behaves like a little a chair, right? Uh, so for example, here it's 0, and then it goes up to 4, then 8, then 12, and that's because we are again splitting at 100 steps, and we have a 400 quantity. That means that each steps represents 400 a quantity of 4, and at the end it remains like this, right? The utilization keeps uh, at its maximum, and it's basically waiting for operations to consume this. Again, think about that. This constraint is, for example, simulating a tank where this tank has a capacity, and the operations are adding product, are adding liquid to this tank, and then other operations can consume quantity from this tank later on, right? Okay. So increment to end, then increment for setup time only. It's very similar for the process time only, but now it's going to be consumed only at the setup time. Of course, if you increase the setup time here, let's say now it's 15 hours, the constraint will also increase its duration. And this can be used for tooling that are assigned at the setup time, people that need to be there during the setup time, and things like that, okay? Coming back to resources. Next one is increment for start of setup. So we have increment from start, and now we have the increment from start of setup. So basically now, instead of going up to its maximum at the start time, it goes up to its maximum at the setup start, okay? Resources again. The last one, it's increment for entire job, which is basically increment for process time and increment at setup time only, but at the same time, right? So the consumption happens at the beginning of the setup time and goes down at the end of the end time of the operation, of the process time, all right? Okay, so this is increment. The difference now with the decrement, it is that it goes negative. So I'm increment for entire job, now I'm gonna decrement for entire job to simulate the consumption, okay? So if you do that, you see that in this case, it goes to negative because there is nothing else supplying a quantity here. So to demonstrate that, let's take a look at relationship between this operation using secondary constraints. So let me put increment for entire job, okay? And let me schedule the next operation here, which is operation 20. Let me put it manually, whatever. Okay. All right, so I assigned this constraint A already to this, so let me remove it for now. Yes, no, okay. All right, so let's say that this operation here, it's going to consume exactly the same constraint, but it requires a 200 quantity, let's say a numerical attribute 1 quantity, and I'm gonna decrement for entire job, okay? So you see that I have, because of those two different periods, an increment for entire job here and decrement for entire job. Decrementation here value, it is, if I come here to attributes, numeric attribute 1 is close to 100. So that's why you see it's going down to 100. Okay, so if I drag and drop this to this position, you see that in this time here, the constraint utilization, it's close to 300, right? If I drag, let me cancel all highlights. If I drag and drop here, you see on the bottom right that my constraint utilization is 300. So remember, I have one operation increasing to 400 and another operation decreasing to, let me put 100 here just to be clear. Yeah, so now one adds 400, another one consumes 100. So at the end, we have 300 in this period here, right? Okay, so let me also do this operation 10. Okay, so they are not linked together. All right, so another thing that we can do, for example, let's say that this operation here has a secondary constraint utilization equal as increment to end. So what you see here right now is that this operation is incrementing to n. So remember, we have that, consumption, increasing of utilization usage of this constraint. And at the end, of course, you have the maximum. And this is consuming 100 for the whole process time. So at this period, that's what you see, right? From here, it goes down to 100, right? And the utilization increase keeps adding up because of this operation. So if I drag and drop this to this position, you see that this is using here. But let's say that I want to automatically schedule this. Let me do something here. I want to prevent this to auto schedule. Okay. Now, let me repair the schedule. So this is what happens. You see that this operation requires 100 since the beginning of the operation. So it waits the chart to go up to 100. You see here, you see bottom right, 96. So as soon as it reaches 100, this operation is consumed at 100. And this operation above keeps adding to this constraint, right? But let's say now that this operation, instead of decrement for entire job, we are decrement to end. Okay, so looking here, you see this is decrement to end also in 100 steps, right? And it's 100, so every step here it's going to be 1, okay? And now I want to repair the schedule. You see here that as soon as we have 1, which is actually 4, because remember, it's 100 steps and we have a 400 quantity. That means that each steps it's adding 4. So as soon as we have produced 4, this here is consuming that 4. And then we have this consumption increase, decrease, right? And it's changing the schedule, right? So before, this operation were waiting to have 100 in order to start. And now this operation can start as soon as we have just a little bit of this equivalence constraint available there. But the end result here is still 300, right? Because this produces 400, it's still producing 400, and this is still consuming 100. So essentially we are changing this when the consumption is happening, okay? Again, this is pretty useful for liquid tanks and process types of schedules, okay? Now let's say that we want to just schedule that we have material, not material, but people constraint. And we have only one available, right? We have one people available. So this constraint A here, it's going to be a head count that both of those operations requires, and we just have one available. So doing so let's change how this resource it is set up. So it's going to be increment for entire job, and it's going to be requiring one person. This is also increment for entire job, and it's also only requiring one. So now you see that this is a valid schedule, right? I'm simulating that I have only one, so I need to change this maximum here to be 1, like this. And this is a valid schedule. But if I now drag and drop this to be here, you see that I am over consuming this secondary constraint, right? And this is not good. When you ask for a schedule repair, of course, this operation will wait for the availability of this constraint in order to be able to schedule. So we have what I try to demonstrate here in this video is that we have two ways, essentially, to configure secondary constraint. We can configure secondary constraint to allow interrelationship between operations, such as one operation producing a certain constraint, another operation consuming that constraint, and we can have ways to limit the capacity as well for shared constraint usage between the same operation. So we limit the maximum value of this constraint, and then Opcenter APS auto scheduling rule will respect that. Okay. Another very quickly here, if you want to create a new constraint, all you need to do is come in here to the secondary constraint. You can duplicate one that already exists, or just double click here at the end. And you see that we have this toggle called use as constraint. So this is going to tell Opcenter APS if you want to use this to actually constrain your schedule, or if you just want to keep track of the utilization charts. And the counter effect here, it is use 100% if you're greater than 0. That means if you have 1% efficiency, I'm going to use the 100% of the quantity defined there. Follow efficient changes means that if I need 400 of a certain constraint and I have 50% efficiency, then I'm going to be consuming 200 of that constraint. Startup job efficiency will look at the beginning of your job, what is the efficiency there, and we will apply that efficiency to quantity consumption of the constraint to the entire operation. And no effect means use 100% of secondary constraint for the duration of the operation. So mean that, for example, if you have 0% calendar, such as a weekend, holiday, whatever, you still are looking for constraint to be used at that time. Okay? And that's it for this video. Thank you.